Welcome back. In this lecture, what I wanted to look at was examples of different types of story problems, specifically ones that are related to your distance, rate, time concept, interest, or average. Okay, now each of those have very specific formulas that have to be used in order to answer the problem. Now, before we get into those formulas, I wanted to do a quick little refresher on a number problem because it helps get the juices flowing for being able to create equations out of applications or word problems given. So here we have 15 subtracted from twice a number is equal to 5 times the sum of a number, or the number, and 12. So let's break this down a little bit. When we're talking about the sum of the number and 12, we are talking about parentheses. And not only parentheses, but we are talking about adding. So the sum of the number and 12 would be what we are adding together. Now that being said, the number, so because it says the number, this is actually referring to whatever variable you choose in the beginning. So it's the same variable that we are working with. Okay, so when we're talking about a number, that is your variable, and the number represents the same variable. Now, the other thing that we know is that we know the phrase is equal to, again, means that this is your equal sign. So essentially it splits your sentence into two parts, whereas the first part you have in the beginning and the second part you have after the is equals to. So we have to work with just this first part to start with. So we're talking about 15 subtracted. So subtracted is just that, it's the subtraction sign. And then when we're talking about the word twice, well, this means 2 times. So knowing all of that, we can be able to start piecing together what we have. So if we look at 15 subtracted from, that means this part goes first and this part goes second. So we've got twice a number, so 2x minus 15 is equal to, and then I have 5 times the sum of. So this is 5 times, we open a parentheses. The number refers to the variable we use in the beginning, so x plus 12. And there we have rewritten our sentence in terms of an expression. So all we have to do here is we just simply have to solve. So we do that by distributing the 5 through. So this is going to be 2x minus 15 is equal to 5x, and then I have 12 times 5, which is going to give you 60, so plus your 60. Then I'm going to take this 2x and I'm going to move it because that keeps my variables positive. Since the 2x is already positive, to move it says I have to subtract. So what I end up getting is I have negative 15 is equal to 5 minus 2 is a 3x plus 60. I need to take this 60 here and I need to move it. Again, since the 60 is positive or being added, to move it says I have to subtract. So I'm going to have negative 15 minus 60, and that gives you negative 75. So here I've got my negative 75 equals my 3x. Divide everything by 3, and you end up with negative 25 is equal to x. And this is the value that we are searching for. So now that we got that out of the way, the first thing I wanted to look at was a distance problem. So when we're talking about distance, we're talking about a very specific formula. D equals RT. In this formula, there's some things that we need to remember. D stands for distance. R stands for rate. And then T stands for time. So you have to be able to read your problem. Now, when we're talking about rate, in this case, we're usually talking about rates of travel. So like miles per hour, kilometers per hour. Your distance might be in miles. And then your time, for the most part, is usually in hours, but you know, it's going to depend on what your problem says. So here we have that Scott is averaging 60 miles per hour on his drive from St. Louis to Memphis. If the total trip is 285 miles, how long should he expect the drive to take? So again, we have to start with our formula. D equals RT. In this case, we're told what D is. My D is the 285 miles. So we have 285 is equal to, my rate is 60 miles per hour, so 60 T. T is what's missing. Now, in here, since we're talking about time, time is given as a decimal. So what that means is, think about a stopwatch. If you were to look at a stopwatch, one of the things that you should notice about it is that it counts up in terms of a decimal. It does not count up in terms of fractions. So when you're dealing with time in your problems, it's safe to go ahead and give your answers in terms of the decimal. So you're going to take that 285 and you're going to divide it by the 60. And in this case, you're going to find out that T is equal to 4.75. And then here, the units are hours. Now the reason we get hours out of that is because of my rate right here is in miles per hour. Therefore, hours is what's left over. Okay. Alright, let's look at another one. So here we have a train leaves Cincinnati at 2 p.m. A second train leaves the same station in the same direction at 4 p.m. The second train travels 24 miles per hour faster than the first. If the second train overtakes the first train at 7 o'clock p.m., what is the speed of each of the two trains? So the best thing to be able to do with this is going to be to draw a picture. So here we're going to draw a picture, and so the first thing we have is I have, say, a train A, and my train A is going to travel in this direction, and we're going at some rate A. Okay, we don't know what it is, but we do know one thing's for sure. We know that it leaves at 2 o'clock p.m. We also know that we have a train B, and we also know that train B is traveling in this direction at some rate B, and it leaves at 4 o'clock p.m. Further, we know that the second train travels 24 miles per hour faster than the first. So my second rate is going to be the same as my rate A plus 24 miles per hour. Okay. We also know these two trains are going to keep traveling until they hit this spot where they're the same place, and this occurs at 7 o'clock p.m. The question is, what is the speed of the two trains? Okay. So we have to look at how long is it taking train A to get from its starting place to the finish line. Well, the time for train A is going to be the difference between 7 o'clock and 2 o'clock. So we have 7 o'clock minus 2 o'clock leaves us with 5 hours. We got to look at the same thing for train B. So the time for B is going to be that same 7 o'clock that we end at minus its starting, which is 4 o'clock, which is going to give us a total of 3 hours. So if you notice, we are putting things together in a way that is going to allow us to solve the problem. So the first thing that we know is that the distance for my train A should equal the distance for my train B. The reason we know that is because both trains are starting out in the same place. They're going to travel the same distance, and so at 7 o'clock, essentially, you would see two trains in the same spot. So your distance is going to be the same. Now, we also know that our formula is D equals RT, and we have to use that kind of for our advantage. So we have the distance for train A, so that means the rate for A times the time for A needs to equal the rate for B times the time for B. So my rate for A we don't know, but we do know the time, 5 hours. So I have the rate for A times my 5 hours is equal to, well, we know the rate for B can be rewritten in terms of the first. So this becomes RA plus 24. And then we also know that its time is 3 hours. So the first thing we have to do is we have to solve for my first rate. So we're going to do that by distributing through your parentheses here. So we're going to have that 5R is equal to 3R, and then we have 24 times 3, so plus 72. So we're going to take this 3, so my 3R, and I'm going to move it to the other side. Since my 3R is positive, to move it says I have to subtract. 5 minus 3 gives us 2. So I have 2 for my first rate is equal to 72. Divide everything by 2, and we know my first rate is equal to 36 miles per hour. Now, that being the case, I also know that in order to find my second rate says I need to take my first and add 24 to it. So the rate for B is going to be 36 plus my 24, which is going to give me 60 miles per hour. And there we have the two rates, and that's all that we needed to do. So for this one, what it really came down to is being able to recognize that if both trains start at the same place and end at the same place, their distances are the same. Alright, let's look at another one. Mr. Kent drove to a conference. The first half of the trip took 3 hours due to traffic. Traffic let up for the second half of the trip, and he was able to increase his speed by 20 miles per hour. to make sure he got there on time. Find his rates of speed if he traveled 2 hours at the second rate. So we have that Mr. Kent is driving along in this direction. And so when we're talking about his trip, he's going to start and he's going to end. So he's going to start his travel and he's then going to end his travel. And we also know somewhere in the middle is where he's going to change directions. So we know the first half of the trip took 3 hours. So we know this one took 3 hours. And we know the second half of the trip took 2 hours. We also know that he has some rate for the first half. And when we're talking about the second half, it says traffic let up for the second half of the trip and he was able to increase his speed by 20 miles per hour. So my second rate is going to be whatever he traveled in the beginning plus an additional 20 miles per hour. So again, we have to set ourselves up to solve. So here we again are going to use the idea that the distance for A is going to equal the distance for B. So we're going to have the rate of A times the time of A has to equal the rate of B times the time of B. In this case, we don't know the rate of A, but we know the time to be 3 hours. The rate of B is the original plus 20, and its time is 2 hours. So again, we need to solve the same way we did before. So the first thing that we're going to do is we are going to distribute through my parentheses. So I have 3 times the rate of A is equal to 2 rate of A plus 40. I'm going to take and combine my terms. Again, since this is positive, to combine it says I have to subtract. 3 minus 2 leaves me with 1, so the rate in the beginning is going to be 40, and this is miles per hour. Now the other thing that we know is we know that the rate of B was the initial rate plus 20. So this is going to be the 40 plus 20 leaves us with 60 miles per hour. All right, interest problems. When we are talking about simple interest problems, one of the things that we might be looking at is that I equals PRT. And in this case, we know I stands for interest. P is essentially principal, i.e. it's what you put in. R stands for rate. It's usually given as a percent. And then T is, again, your time. Okay? So knowing some of that information, we're going to look at these problems and we're going to see how exactly we are solving or what it is that we're looking for. Now in this, it says, after receiving a 10% off coupon in the mail, Mark decided that it was time to buy a Blu-ray player. Using the coupon and paying 8% sales tax, the final price came to $213.84. What was the listed price of the Blu-ray player? So we have to look at what we know. First, we know that your total cost is going to equal your price plus your tax. So if we look at what we have, my total cost was $213.84. We don't know what the price is yet, and we haven't worked out how to solve it, but we do know what the tax is. So your tax is going to be 0.08, because that's 8%, and that would be 8% of whatever your price is. So we have to actually figure out how to find price. Well, there's one thing that we need to note here. So when we are talking about cost, your actual selling cost is whatever your price was minus your discount. So let's think about that. I have a total of $213.84. I also have a 10% coupon, which means when I'm talking about price, I am talking about whatever my price was and then subtracting 10%. So subtracting away 0.1 of whatever that price was. I then have to add my sales tax, which your sales tax would then be 8% of whatever that price was. So here what we have to do is we have to solve for x. So the first thing that we need to do in solving for x is we need to distribute through our parentheses. Actually, nope. What we actually want to do is we want to do our order of operations, which says we're going to combine inside the parentheses first. So our total is still $213.84. Now, let me preface by saying you could go ahead and distribute through. You're going to end up combining either way, but giving it a second thought, this is going to make things a little bit more simpler. So we have 1 minus 0.1 is going to leave us with 0.9x, and then I'm going to add that to 0.08 times the same thing, 0.9x. Now we're going to go ahead and do this multiplication here. So I have still that 213.84 is equal to 0.9x plus, and when we multiply this together you get 0.072x. We need to combine my x's together. So 213.84 is equal to 0.972x, and then to solve for x says we need to divide. So in this case we're going to find out that x is $220. Okay. So what this problem came down to is it came down to recognizing how coupons work and how tax works. So when you're working problems like these, if you get stuck, just picture yourself going to your favorite store. And then picture that when you walked into that store, you had a coupon. And then talk yourself through how does that coupon actually get applied when you're standing at the register. Because let's face it, we all manage our pocketbooks very, very closely. And if you're anything like me, in that you're always rubbing 2 coins together and hoping you get gold, when you're standing at that register, you watch that thing like a hawk. So you pay attention to what your subtotal was, which would be, your price, and then you go from there. So if you get stuck again, just kind of picture yourself walking into your favorite store, and then look at what you would go through and before you would actually say, hand over your credit card. Okay. Now let's look at a different problem. Here I have 2 investments totaling $16,000, produce an annual income of $1,140. One investment yields 6% a year, with the other yields 8% a year. How much is invested at each rate? So first and foremost, we need to look at what we know. Well, we know that I make an income of $1,140. Okay, I don't know if I'm going to have to use it yet or how, but I do know that that's going to be important. This income here is what we like to call your interest earned. Now that being said, I have two investments. So X plus Y equals my $16,000. What also do I know? I know that my first investment yields 6%. So 6% as a decimal says you're going to take your 6% and you're going to divide it by 100%. So this gives you 0.06. Okay, so mini lesson in converting your decimals. So here I have 0.06x, and the other yields 8%, so 0.08y, and the total together would be my interest earned, $1,140. So here, one way to do it would be to take this top equation here, and you are going to solve for one of the variables. So for example, let's say that we wanted to solve for x. So to do that, it says I'd move the y to the other side. It tells me that x is equal to my 16,000 minus y. Now, the other thing that I would then do with it is I'm going to be able to take this part of the equation, and since this is what x equals, I can substitute it into my x value. It takes a two variable equation down to one variable. So this becomes 0.06 times 16,000 minus y plus 0.08y equals 1140. I only have one variable, so now I can go ahead and solve. I'm going to distribute my 6% through. So this becomes 960. And then minus 0.06y plus 0.08y equals 1140. I'm going to combine my y's together. So this is 960 plus 0.02y is equal to 1140. I'm going to take this 960 and I'm going to move it to the other side. Because it is positive, to move it says I have to subtract. So I'm going to get that 0.02y is equal to, and I'm going to do my 1140 minus my 960, which gives me 180. I then have to divide both sides by 0.02, so I end up with y equals 9,000. Since I know what y is, the very easiest thing to do is to take this value here and plug it back in from my y into this equation, because that already tells me what x equals. So here I'm going to get that x is the 16,000 minus 9,000, which gives me a total of $7,000. Okay. All right. the last one I wanted to look at is an average problem. So when we're talking about average, average says you need to add up all your values and divide by the number of values you added together. Okay? Sometimes you will have a missing part, so you have to be able to input that into your equation. So here we have that Wade has scores of 59, 68, 76, 84, and 69 on the first 5 tests in his social studies class. He knows that the final exam counts as 2 tests. So what score will he need on the final exam to have an average of 70? So we have to add everything up. So this is the 59 plus 68 plus 76 plus 84 plus 69 plus 2 of the final scores. So how many did we actually add? Well, we have 1, 2, 3, 4, 5, and 6, 7. So this is 7. And we know that he wants to have an average of 70. So here you're going to add up all your numbers. So this is going to become 356 plus twice the final divided by 7 equals 70. I'm going to multiply both sides of my equation by 7. So here my 7's are going to disappear, so I'm going to be left with 356 plus twice the final is equal to 490. I'm then going to subtract the 356. So I have twice the final equals 134. Divide everything by 2, and your final is going to come out to being 67. Okay. So there you have it. That's everything you need to know about doing distance, rate, time problems, different forms of interest problems, and average type problems. So if you have any questions, please let me know. Otherwise, be sure to relax, have some fun, enjoy your math, and I'll see you next time.